Welcome everyone. Today we're going to continue our discussion about trigonometric functions, and today we're going to move past our basic ratios that we did in video number 1, and we're actually going to look at solving for measurements of sides and angles within that right triangle. So our learning target is still going to be understanding how those trigonometric functions relate to right triangles, and we're going to now continue on solving those problems involving those right triangles. So just like in the previous video, we need to be able to identify the hypotenuse, the adjacent side, and opposite sides of an angle in a right triangle. We need to determine those three basic trigonometric ratios, which was our sine, cosine, and tangent. And then today we get to spice it up because we actually are going to look for finding the missing lengths and the angles of a right triangle. So I'm going to start us off by actually finding the measurement of a side. So I'm just going to throw that up here. The measure of a side. Right? So let's say we have this little triangle. I don't know if it's really little, right? And we know that when it comes to our trig functions right now with our sine, cosine, and tangent, we know that we need a right triangle. And I'm going to name this triangle ABC, right? Capital letters go for angles, lowercase letters go for sides. And I'm going to say that this angle A, is 56 degrees. I know that. And I know that this side is x. And I know that my side down here is going to be 6. So ultimately, I need to find the length of BC. I can't use Pythagorean theorem on this one, right? Because in order to use Pythagorean theorem, I need to know 2 of the 3 sides. So this is where trig comes in handy because we can't use the Pythagorean theorem. So if I go back to my little mnemonics, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, that's SOHCAHTOA. So I need to figure out what it is that I need. In order to solve this problem for x, I'm either going to need sine, cosine, or tangent. So the first thing I need to do is figure out which one of those 3 I'm going to need. And we know that when we're using trig that we are looking at angles. So I have this 56-degree angle, which they gave me. So off of this angle, there's a relationship to this side and to this side, and I need to figure out what that relation is. So when I look at my little problem, from 56, my x, if I go to the opposite side of my triangle, that's my opposite side. So I know this is going to be my opposite side. When it comes to the 6, it's either going to be my adjacent or my hypotenuse. I know it can't be my hypotenuse because my hypotenuse is always straight across from my 90-degree angle. So this one has to be adjacent, right? And it's touching this side, so I know that this is my adjacent. So when I look over at my mnemonic, SOHCAHTOA, and I'm looking at opposite over adjacent, or opposite and adjacent. So which one of the 3 has opposite and adjacent? Tangent does. So I know that I have to use tangent in order to solve this problem. So, oops, we don't need no highlighter. Let's go on the pan. I think I'm on the right one now. We'll try. So I know I'm going to use the tangent, and it always comes from an angle. So I was able to pick up that opposite and adjacent because I was looking at that 56-degree angle, right? So the tangent of 56 equals opposite. Which side was my opposite? X. Over my adjacent, which was 6. So now I have an equation. And technically, if I wanted to, I could throw this over 1 to where now I have 2 fractions or 2 ratios. And I know when it comes to ratios, like we usually just kind of say, cross multiply. But ultimately, because they are equal, we know that the numerator times the denominator of one fraction has to equal the numerator times the denominator of the other fraction, right? That's where we come up with that little cross multiply kind of part. So numerator to denominator, I'm going to get 6 times the tangent of 56 equals numerator times denominator, x times 1 is just going to give me x. When I do these problems, a lot of times I like to throw that tangent of 56 right in those parentheses. The tangent of 56 is one number. Even though we're writing the tan and we have this little space here and then this 56, this is not two different numbers. This isn't two different operations. This is not a multiplication. This is just a way of writing a number, and we're writing it as the tan of 56, right? So my ultimate goal is to get x all by itself. X is all by itself. I can type this whole part into my calculator, 6 times the tangent of 56. And I'm going to get where x is approximately 8.9. And that problem is complete, right? Not too shabby? All right. So let's spice it up just a little bit. So let's say we have a triangle. Guess what kind of triangle we're going to have? Yep, a right triangle. And we're going to name it ABC. Or you can name it XYZ if you want, right? I'm going to say that this side is 4, this side is X, and I'm going to say angle A is my 32 degrees. So again, I know I can't use Pythagorean theorem because I technically only know one side. In order to use Pythagorean theorem, I need to know 2. So I'm going to use trig functions. So either so, ga, toa, right? So for my 32 degree angle, because I need to go for my angle, I need to figure out what two sides I have. Which one do you want to pick? So we got 90 degrees across from here. This is going to be my hypotenuse. This one is either got to be adjacent or hypotenuse because it's touching it. We know the hypotenuse is across from the 90 degree, so that has to be my adjacent. So when I look over at my SOHCAHTOA, I have hypotenuse and adjacent. So I'm looking for A and H. If I'm looking for A and H, it's right there. So I know I have a cosine problem. So I have, oops, me and that highlighter. All right, so I know I have the cosine, and the cosine of what angle? 32. And that's going to equal, what is it? Adjacent over hypotenuse. Adjacent is 4, hypotenuse is x, right? If it makes us warm and fuzzy, throw it over 1, and we're going to cross multiply. So I'm going to get x times the cosine of 32 equals 4. My ultimate goal is to solve it for x, so I have to get x all by itself. So the way this problem is written, I need to get rid of that cosine of 32. So this is x times the cosine of 32. So I need to divide both sides by the cosine of 32. That's going to cancel this all out, right? And what am I left with? X equals 4 over the cosine of 32. We can plug that into our handy dandy little calculator, and we get approximately 4.7. Not too bad. All right. So I think we got it with angles, with sides. Might need to go back and maybe review one. Maybe if you guys are still having trouble, I can create a third video for the week if we need to. So now I think, though, we have at least a basic or at least a little understanding of when it comes to sides. Let's spice it up and sit there and say, like, we need to find the angle. And how does that work? So we need to find the angle measure. Right? So again, we're going to have a fancy little right triangle. You know it's a right triangle because of that really bad square I just made. Right? I'm going to name it triangle ABC. I'm going to say that this bottom piece is 3. This guy over here is 5. And I want to find out what that angle is. And I'm going to call that angle theta. See, straighten this up a little bit for you guys. A little bit better, maybe, hopefully. All right. So we're going to start these off the same way that we've been doing it. We know that we're looking for the angle, so we can't even use Pythagorean theorem to figure out the angle. You could use Pythagorean theorem to figure out that third side, right? You could figure out this one, but that's not what we're looking for. We're looking for that angle. But still, we need to sit there, and we're still going to use trig. So we're still going to look at SOHCAHTOA. And we're still in that same process, right? Anytime we use trig, we're going off of the angle. So we're going off of this guy right here, our theta. Even though we don't know what that measurement is right now, that's the angle that we're talking about. So from this angle, we need to figure out these two sides. So from this angle, to get to 3, I'm going to the opposite side of the triangle. So that's ultimately telling me this is the opposite side. And then this is either, it has to be my adjacent or my hypotenuse. And because it is straight across from the 90-degree angle, we know that this is the hypotenuse, right? So I'm going to go over and I'm going to look at my SOHCAHTOA, and I'm looking for one that has H and O. And can we find any of them that have H and O? H and O. Oh, look at that. Sine. So let's start writing it out. So we know that we're looking at the sine. I hope you guys are laughing at me. All right. So the sine, and the sine of what angle? Angle theta equals opposite 3 over our hypotenuse 5, right? So sine theta equals 3/5, and ultimately we're looking for theta. So we need to figure out a way in order to get that little guy, our theta, all by itself. So let's take a little side step for a second. There's this little thing called a multiplicative inverse. And a lot of times when we talk about multiplicative inverse, we really just focus on this word inverse, right? So if I take the number 5 and I multiply it by its multiplicative inverse, so I'm multiplying it by 1/5, I end up getting 5 over 5, which equals 1, right? So there's this thing in mathematics where if we multiply by the multiplicative inverse, we're going to get 1. So the same thing holds true when it comes to trig functions. So if we take sine and we multiply it by sine inverse, our sines will cancel out and we'll be left with our theta. So if we have the sine inverse, so that's how we write it for trig functions. We just put the little -1 up there. It's not to the -1 power, it is the inverse, times sine theta. And if we do it to one side of the equation, we have to do it to the second side of the equation, right? Because it's a balance. So we would take the sine inverse of 3/5. So sine inverse times sine is going to cancel out. And then the only thing we're left with on the left is theta. So theta equals the sine inverse of 3/5. And then we can plug that into our calculator. Usually you got to hit the second button on the sine. So the second sine will get you to the inverse. And if you put in the inverse of 3/5, we will get approximately 36.9 degrees, right? Because we're actually looking for an angle measurement. Let's go ahead and do one more example. So let's make a triangle, a nice little fancy right triangle. We'll go A, B, C. I'm going to say this is my angle theta. I'm going to go with a 10 here, 10 units. And this side is going to be 2.9 units. So again, on this problem, I want to figure out my theta. So I'm going to think of SOHCAHTOA. And now I need to figure out my sides. So from my theta, I can see that my 2.9 either adjacent or hypotenuse, and it has to be adjacent because across from the 90-degree angle would be my hypotenuse. So if I am doing adjacent and hypotenuse, so I'm looking for A's and H, I'm looking for cosine. So the cosine of my angle, and my angle is theta, and that's going to equal adjacent, which was 2.9 over 10. So my goal here is to get theta all by itself. So to get theta all by itself, I have to get rid of the cosine. And this is not multiplied, right? These are together. So the only way I can get rid of my cosine is by taking the inverse of both sides, right? So the cosine inverse of cosine theta equals the cosine inverse, because if I do it to one side, I have to do it to the other, of 2.9 over 10. My cosines are going to cancel, right? And then I'm going to be left with theta equals cosine inverse of 2.9 over 10. Some people throw these in parentheses, which is perfectly fine. Most calculators will automatically give you that first set of parentheses as soon as you put in a trig function. And I'm going to plug and chug that into my fancy dancy handy dandy calculator, and I'm going to get 73.1 degrees by rounding to the nearest tenth. Hope these videos help. Let me know if you want me to create another one with just some examples on these types of problems. Take care. Talk to you later.